Fifth grade into math, lesson 13.4, comparing order decimals. I can use place value to compare order decimals to thousands. Step it out. Number 1, the field goal percentage in basketball is found by dividing the number of baskets made by the number of baskets attempted. Okay, so I told you how they got their percentages of the ones named. Hector compares the field goal percentages for Thomas and Lucas. Letter A, compare each place value working from left to right until you find a digit that is different. In which place value are the digits different? So we've done this before on our bucket, right guys? Okay, where we started from left to right and then worked our way across to find a difference. So basically, we are comparing these two right here, right? Okay, so is the 1 different? Nope, they both have a 0, so we're not looking at it. Okay, what about the tens? Nope, they both have a 4, right? What about the hundreds? Same, 7 and 7. And then the thousands have what? 8 and a 3, so we're looking at the thousandths place. Compare the digits of the place value that you found in part A. Use the less than symbol. So we have an 8 and we have a 3. So 3 is less than 8. Compare the digits using the greater than symbol. So in this case, you would say 8 is greater than 3. Compare the field goal percentages for Thomas and Lucas in 2 different ways. Use the less than symbol and the greater than symbol. So we use the less than symbol. We said 3 was less than, right? So we would have 0. So we'd have 473,000 is less than 478,000. Or you could write it as 478,000 is greater than 473,000. Which player has the higher field goal percentage? Thomas. And then the less than symbol is the symbol used to compare 2 numbers or 2 quantities with the lesser number or lesser quantity given first. The greater than symbol is the symbol used to compare 2 numbers or 2 quantities when the greater number or greater quantity is given first. Okay, and we did that for letter D, right? Okay. Step it out. The table shows the field goal percentages of 3 players. What is the greatest place value position in which you find a digit that is different? So we start at the 1s, right? Okay, are they the same? Yeah. So we're not looking at the 1s. What about the 10s? Yep, they all have what in them? 4. Okay. Now the hundreds. 1 has a 4, 1 has a 5, and 1 has a 4. So are those all the same? No. So that place value is where they're different. So 100. Okay, you have to go where you see it first. Okay. Now we might get to where we need to compare the other 2, and then we would move to the thousands. But right now, our first difference is in the hundreds. Use your answer from part A. Which player has the greatest digit in this place value position? So who has it? Robinson. Okay. Move to the next lesser place value position and compare the digits of the other 2 teams or other 2 players. Okay. So basically, we've gotten rid of our 100 place value now, right? Because the other 2 are the same. So now we're comparing the what place value? The 1,000. Okay. So which player has the greatest digit in this place value? 11. Okay. Order the players by name by their field goal percentages from greatest to least. So who had the greatest? Robinson. Okay, then Ortega. check understanding. Order from the greatest to the least. Okay, so looks like we go clear to hundreds, right? Okay, so let's look at the hundreds place values. They all have what in them? 4. Okay, what about the 10s? 7. They all have 7? Yes. Yep. What about the 1s? They all have a 5, right? Okay. What about the 10s? No, we have a 3, a 4, and a 2. So of those, which one's the greatest? The 4. So we're going to write 475 and 412,000. Okay, that's our first number. And then we can cross that one off because we've used it, right? Okay. Now we have 2 that have a 3. So we can go ahead and mark those off. And then now in the hundredth spot, we have a what? A 1 and a 2. So our next one would be 475 and 321,000. Then and we can go ahead and mark that off. That number, we used it. Now, am I scribbling these out? No, I'm putting simple lines through them in case I have to come back, right? Okay. Then our next one will be the 475 and 314,000. And then now we can move to the one that had the 2 in the what? 10th spot, right? So then our last number is 475 and 296,000. Okay. All right, compare with less than, greater than, or equal to. So looks like we're starting at the 10s, right? Do I have the same number in the 10? Yes. Yep. What about the 1s? Yes. Yep. What about the 10s? Yes. Yep. What about the 100s? No. Nope. So I'm comparing the 2 and the 3. So 76 and 924,000 is less than 76 and 931,000. Okay. All right. Let's go to the next one. Looks like we're starting in what place value? Thousands. Right? Okay. So 5 in both? Yep. Hundreds? Yep. 4s, right? 10s? 1s? Yep. They're both 6s. 10s? Yep. Yep. Both 3s, right? 100s? Yep. Both 2s. So we're going to compare the 9 and the 6. So 5,486 and 329,000 is greater than 5,486 and 326,000. On your own, number 4, attention precision. The table shows the free throw percentages of 4 players. Order the players by name by their free throw percentages from least to greatest. So that is also something else you guys need to pay very close attention to, is that they don't always want you to go greatest to least. Sometimes they want least to greatest, and you have to pay attention to what they're asking. Okay, so in our one spot, what do we have? All zeros. All zeros. Now, since sometimes it's easier to get the greatest one first, could you also write them backwards in order? Yeah, you could do that. Might go a little easier, right? Okay, so we have a 7, a 6, a 7, and an 8. So which one of those is the least? Samson. So Samson. Now, I could have also written at the very end, I could have written who? Lee. Okay, and then work backwards. Okay. All right. Now, which one is the next? So we have 2 7s, right? So those kind of cancel each other out. So we have a 9 and a 9 again. So those cancel each other out in the hundreds. So now we're comparing the 6 and the 4. So which one is the least of those? Okay, so Carter. Okay, and And then we have Randall. Okay, and then we're left with Lee. What are the possible digits that make the statement true? Right? So basically, our 10 is the same, right? Our ones are the same, correct? Okay, and basically the hundreds and the thousands are the same, right? Okay, so in order for 3 to be greater, what could it be? 2, 1, or 0. So 2, 1, or 0. The decimal 237 and 57 thousandths is greater than another decimal by 100. What is the other decimal? So, what number is in the hundredth spot? 5. Okay, and it says that it is greater than that. So that means you would have to add 1 or subtract 1 from that spot. Subtract, because it says this one is greater than, right? So we would rewrite 237 and write a 0, and we said we would subtract 1, so 4, and then the 7 stays the same. Compare, right? Less than, greater than, or equal to. Take our 1 spot. Same. 10? 100? No, the 9 and the 7. So 8 and 391 thousandths is greater than 8 and 371 thousandths. Okay, and remember, I want to see work on these, so you have to be marking out. Okay, next one, 10. They both have a 2. 1. The same. 10s. No, we have an 8 and we have a 0. So 29 and 808 thousandths is greater than 29 and 88 thousandths. Okay, next one. 1. Same. 10. Different. So 6 and 91 thousandths is I have a 0 and I have a 9. So 6 and 91 thousandths is less than 6 and 91 hundredths. Okay, right here, 1, same, 10, same, and then technically you could put a 0 at the end, right? So these are equal to, okay, 1, different. So I have a 1 here and I have a 2 here. So 1 and 532 thousandths is less than 2 and 42 hundredths. Okay, next one, 10s. Different. So I'm going to circle the 2. I'm going to circle the 1. So 23 and 742 thousandths is 13 and 72, or 13 and 742 thousandths. Number 13, reason. Given 2 numbers, if all digits in the right or to the right of the decimal point are the same, is it true that the 2 numbers are equal? Not necessarily, right? Okay, because it said all the digits to the right, they might all be the same, but what if you have a 1 over a 10 or 100 and they're different on the left side? So would they be equal then? No. Okay, so it's not always equal. Just because the ones have the decimal to the right. Alright, cool. Okay, so my recording is probably going to run out before we get finished with this page, but we will finish the page, okay? So you should have something written on each problem. Number 14, in baseball, the batting average is found by dividing the number of base hits by the number of times at bat. The table shows the batting averages for 4 baseball players. Order the players by name from greatest batting average to least batting average. Okay, so they went greatest to least this time, right? Okay, what about our 1 spot?